This is one of the favorite doubts of calorimetry for class 10 ICSE. This is the question that talks about 50 grams of metal of SHC 0.8 joule per gram per Kelvin is heated to 595 degrees Celsius and quickly transferred into 250 grams of water at 30 degrees C in a calorimeter of mass 100 gram and SHC 0.4 joule per gram per Kelvin, and calculate the temperature of the metal at equilibrium. That means when the heat exchange is finished, when the heat lost is equal to heat gained till the equilibrium temperature is attained, and that is the temperature we have to find. So for that, it's easier with the columns drawn the way I show you. So we make the table like this. We will write here substance, we will write mass, and then we'll write SHC, that is specific heat capacity, initial temperature T1, final temperature T2, and delta T is the change in temperature. So 50 grams of metal, so our first substance is metal and the mass is 50 gram, and this is the SHC. .8 joule per gram per Kelvin. It is heated to 595, so your T1 is 595 degrees C, and T2 is the equilibrium temperature, which is the final temperature we do not know. So we'll call that as X. Now it is quickly transferred to water. So the second substance is water. The mass of the water is 250 gram. And it is at 30 degrees C, that's initial temperature, and in a calorimeter, so the calorimeter is going to receive the heat, mass of it is 100 gram and SHC is 0.4 joule per gram per Kelvin. And because water and calorimeter, they are in contact with each other, the initial temperature of the calorimeter also will be 30 degrees C, and the final temperature is going to be the equilibrium temperature, which will be X. Now the metal is at a higher temperature, it's going to get cooler, so we will have delta T as 595 minus X, higher minus the lower temperature. Now when the metal is at 595 degrees C, when you drop it in water, the temperature of the water and the calorimeter is going to increase. So X is going to be greater than this. So you will have X minus 30 and X minus 30. This would be the delta T in Kelvin or in degrees C for water and calorimeter. By the principle of calorimetry, we are going to have the heat lost by the metal is going to be equal to the heat gained by the water as well as the calorimeter. Now the heat lost by the metal, let us call that as M1C1 delta T1. Why? Because the heat absorbed or given away, it is MC delta T. Okay. Now heat gained by water, let us call that as M2C2 delta T2, and plus the calorimeter also will have its mass M3C3, and delta T2 will be the same for this also, delta T and delta T for water and calorimeter. Can you see it is the same? So I'm writing delta T2. Let us substitute. So we have M1 for metal is 50 gram multiplied by SHC is 0.8, that is 8 upon 10, and delta T is 595 minus X. Okay. For water, what do you see here? Mass. M2 will be 250 gram multiplied by, now C2 has not been supplied, but I think by now everyone should know that it will be 4.2 joule per gram per Kelvin. Okay, so C2 will be, I'll write as 42 upon 10, and delta T2 will be x minus 30. Yes, and the calorimeter M3 will be 100 gram. The SHC is given as 0.4, that is 4 upon 10, and delta T2 is the same as water, right? So it is x minus 30. Now let us see how we can do the cancellation. 8 5s 40 into bracket 595 minus x, and that is equal to, here it will be 25 2s 50, carry 5, 25 4s 100, and 505. So 1050 into x minus 30. And here it will be simple calculation here, 40 into x minus 30. Now here there are two ways of solving this. You can either take the whole thing and divide by 10, and then you can add these, or you can write this as 40 into 595 minus x, and that is equal to, now can you see this is 1050 of some quantity plus 40 of the same quantity. So if I call this as m and this also as m, then 1050 m plus 40 m. Okay, so if you add this 1050 plus 40 is 1090 times x minus 30. Alright, now you can divide the whole thing by 10, or you can just simply cancel this. So we can open the brackets now because we have to find the value of x, right? So 4 5s 20, carry 2, 4 9s 36, 38, carry 3, 4 5s 20, and 3 23. So 2380 minus 4x is equal to 109x minus, it is 3 9s 27, carry 2, so 3270, correct? Now we will have 109x plus 4x, and this quantity comes that side, so 2380 plus 3270. Let's add this. 8 and 7 15, carry 1, so we have 6, so 5650, and here it will be 113x. Okay, so our x will be equal to 5650 upon 113. Now can you see 13 5s are 65 and 1 5 is 5. So this is going 50 times. Can you see that? So we'll say therefore the equilibrium temperature is equal to x, which is equal to 50 degrees C, and that is our answer. If you understood, you can like the video and you can share it with your friends. But if you have any doubts in physics, chemistry or mathematics, class 9 or 10 ICSE, type them in the comments below in this video and I'll solve them as soon as I can. Also, my offline coaching classes have reached full capacity and I will not be able to enroll any more students offline. However, due to so many parents calling me, I'm making my classes available online for the first time ever. To enroll to the online classes and learn at your own pace, click on the link below and I'll see you in class.